Question number 19. If the diameter of a sphere is multiplied by 4, the surface area will increase, and we're supposed to say by what factor here. So I've got two different solutions here. The first one, you could use a specific case. So for example, let's say the radius was 3 centimeters. Now it says the diameter is multiplied by 4. If the diameter is multiplied by 4, then the radius would also be multiplied by 4. So the reason I'm working with radius here is because the formula is 4 pi r squared. There's no diameter in this. It works with the radius. So for example, let's say the radius was 3, and there's no particular reason I took 3. I could have taken 2 or 8.6. It really wouldn't matter. So here's my example. I'm using 3 centimeters. And if we multiply it by 4, so okay, it's being multiplied by 4, then the newer, larger sphere would have a radius of 12 centimeters. So we're going to find their surface areas and compare them. So the smaller one, the one I'm starting with, the radius 3 one, 4 pi r squared, we'll put 3 in place of r, and so 4 pi times 3 squared, and I'm going to bring my calculator over and do this. So in fact, maybe I'll bring it right here. So 4, I guess better turn it on first, 4 times pi, and if you use 3.14, it wouldn't matter, times 3 squared. Works out to that. So that's where I get the 113.1 from. That would round to 0.1. In the second one, I'll do the same thing. 4 times pi times now, so the radius is 12. Remember, it's 4 times bigger. 3 to 12. So 12 squared. And so that's where I get my 1809.6 from. That would round to 0.6. So we're gonna compare them. So actually, maybe we'll bring it back here. So we're going to divide the 1809.6 by the 113.1. So 1809.6 divided by 113.1 works out to 16. So that means that the larger sphere has a surface area 16 times bigger than the smaller one. So to complete the sentence, the surface area will increase by a factor of 16 because this number is 16 times bigger than this number. Now, so that's one way to solve it. Use a specific example. Another way is to just look at the surface area formula. And so here's our surface area formula, just up here, 4 pi r squared. But instead of using a specific example, I'm going to call r the original one. And I'm going to call the bigger one, it's got a radius of 4 times the value of r. So I've changed the r into 4r. It's 4 times bigger. If I multiply r by 4, it will be called 4r. And so if we square 4r, you remember you square everything in the brackets, so the 4 gets squared to 16, and r squared would be r squared. And so now if I bring the, I'm just, from this line to this line, I'm just rewriting this. I'm putting the 16 in front. Okay, so there's the 16, and here's the 4 pi, right there, 4 pi, and then the r squared. And the reason I'm writing it like that is because this is actually the surface area of the original. Remember, it was 4 pi r squared. And so this 16 here, 16 times, is why it's 16 times larger. So since the 4 pi r squared, this part, is the original surface area in my solutions, then 16 times that 4 pi r squared means it's 16 times the surface area of the original sphere. So that's another way to solve that. And so both of those would be answer D for question 19.